Hello class, today we're going to be looking at section 8.1, the rectangular coordinate system. We are going to look at plotting ordered pairs in a rectangular coordinate system, finding the distance between 2 points using the distance formula, and finding the midpoint of a segment using the midpoint formula. Now, 3, 2 is an example of what we call an ordered pair, a pair of numbers written within parentheses in which the order of the numbers is important. The two numbers are the components of the ordered pair. An ordered pair is graphed using two number lines that intersect at right angles at the 0 points shown on the next slide. Now, the 0 point is called the origin. It's there in the middle, as you can tell. We have an x and a y-axis, so x-axis, y-axis, and we have different quadrants, the first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay. Now, if we wanted to plot some points here, I'm plotting the point -3, 0. I'm going to go left 3 on the x-axis, 1, 2, 3, and put a point at -3, 0. If I wanted to plot a point at 0, 1, I would go nowhere on the x-axis, but I would go up 1 on the y-axis and plot that. Now let's go back to that point 3, 2. That means I travel right 1, 2, 3 on the x-axis and up 2 on the y-axis. I could plot that point there. If I wanted to go to 2, -3, I would go 1, 2 to the right and 1, 2, 3 down. If I wanted to plot -1, -4, I would go to the left 1 and then down 1, 2, 3, and 4. All right, let's look at the distance formula. The distance between the points x1 and y1 and x2, y2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. This is known as the distance formula. Okay, so let's find the distance between 1, 2 and 5, 7. Okay, so let's start with this distance formula here. Now this is going to be our x1, this is going to be our y1, this is going to be our x2, this is going to be our y2. It doesn't matter which one goes with which. Like I could have made this x1 and this one y1 and this x2 and this one y2. The only thing is you need to stay consistent. The x1 needs to go with the y1 and the x2 needs to go with the y2. Can't mix and match. So here's what we do. We take the x2, which is 5. Got to plug that in here. Subtract that from the x1, which is 1. Square it. We're going to take the y2, which is 7, subtract that from the y1, which is -2. We're going to square it. Okay. Now we just have to work through. 5 minus 1 is 4, so we're looking at 4 squared. 7 minus a -2, same thing as 7 plus 2, that's 9 squared. Okay. 4 squared is 16. 9 squared is 81. 16 plus 81 is 97. And then we would take the square root of that, of course. Okay. The midpoint of a line segment is the point on the segment that is equidistant from both points. Okay. So we also have what's called here the midpoint formula. The coordinates of the midpoint of the segment with endpoints x1, y1, and x2, y2 is x1 plus x2 all over 2, comma y1 plus y2 all over 2. Essentially just taking the averages of both of those points. So let's find the coordinates of the midpoint of the line with the segment with endpoints 1, -2 and 5, 7. Okay, so we need to look at x1 plus x2. Remember this is x1, y1, x2, y2. So we're looking at 1 plus 5 over 2, comma, and we've got to look at our y's, -2 plus 7 over 2. So it looks like we're looking at 6 over 2, comma, 5 over 2. Okay, which obviously does reduce here to 3, comma, 5/2. Okay. Now, let's apply the midpoint formula to the data. The figure shows how a graph can indicate the increase in revenue generated by fast food restaurants in the United States from $69.8 billion in 1990 to $164.8 billion in 2010. Use the midpoint formula and the two given points to estimate the revenue from fast food restaurants in 2000 and compare it to the actual figure of 107.1 billion. Okay, so if we want to use this midpoint formula here, we've got to use this point. So our x1 here would be 1990, and then our y point would be 69.8. So you can see where that comes from. And our second point here would be 2010 and 164.8. Those are the 2 points that we're working with. We're going to use the midpoint formula here to do this. So we're going to add 1990 plus 2010 and divide by 2. And then we're going to add our y's, the 69.8 plus the 164.8, and then we're going to divide by 2. Okay. Now, 1990 plus 2010 divided by 2 gives us an average of 2,000. And then 69.8 plus 164.8 divided by 2 gives us 117.3. Okay, our estimate of 117.3 billion is greater than the actual figure of 107.1 billion, but it's reasonably close considering the graph here. Okay. That concludes this lecture. If you have any questions, shoot me an email. Otherwise, I will see y'all next lecture.